Ew, that looks ugly. Okay, hopefully you can see the axis behind it. If I was to flip this about the origin, so like this, it looks exactly the same. If I was to start and flip it about the x-axis, so right here, flip, it looks exactly the same. And if I was to flip it about the y-axis, do this, and flip, once again, it looks exactly the same. So it makes sense that it is symmetric about the x-axis, the y-axis, and the origin. Okay, one more page to go. Yeah, one more. So same thing, we're trying to check for symmetry for all of these examples. So here we go, let's check for the x-axis, which means we're going to plug in negative y. So go ahead and plug that in and see what you get. Okay, so plugging it in, we have x times negative y equals x squared negative y cubed. That times that is going to be negative xy absolute value equals x squared. Well, quantity cubed, if it's negative, is still going to be a negative. So simplifying this out, absolute value of a negative is actually going to be positive. Equals, oh, but we have x squared times negative y cubed. That's going to be negative x squared y cubed. This is not the same equation I started with. Okay, so that means it is not symmetric about the x-axis. Okay, we did not get back the same equation. Let's try the y-axis. Plug in negative x. So plugging in negative x, negative times positive is going to give me negative xy equals, oh, a negative value squared is going to give me a positive value. And then the absolute value of a negative will give me back just that positive value. And so there we go, it's all simplified. Does that look like what we originally had? Yes, it does. It's the exact same thing. So it is symmetric about the y-axis. Awesome. Okay, last one to check. Origin. Negative x, negative y. I'm going to speed this up a little bit. So plugging in the values, we have negative x times negative y equals negative x times, negative x squared, negative y cubed. Simplifying, that'll be x times y, x squared times negative y cubed, xy, equals negative x squared y cubed. Is that what we started with? No, so this is not symmetric about the origin. And normally you'd write out the word symmetric, but I'm running out of space here. Okay, here we go. Let's check y equals x cubed. Go ahead, pause the video, see if you can check this, and then check your answer back with me. All right, so here we go. Plugging in the values. So for negative y, we have negative y equals x cubed. That is not what we started with. So it is not symmetric. Not symmetric about the x-axis. Sad. Okay, let's check the y-axis. Plugging in the negative, we get y equals negative x cubed. Simplifying, y equals, well, a negative value cubed is still going to end up being a negative value. That's not what we started with either. So it's not even symmetric about the y-axis. Shucks. Is it going to be symmetric about the origin? Well, that'll be interesting. Okay, plugging in the negative y and the negative x. Let's see, opposite of y stays that way. A negative value cubed, still going to be a negative. Oh, but I can simplify this. If I multiply this across by -1, I get y equals x cubed, which is what we started with. See that little trick there with the -1s? Impressive. Okay, so this is symmetric about the origin. Awesomeness. Okay, so that's how the check goes for all of them. You check the x, check the y, check the origin, and write out whether it is or not symmetric. Lastly, let's check this for symmetry and graph it. Okay, so x-axis, we're going to set y to 0. Set y to negative. So we have -y squared equals x plus 4, which that's going to be y squared equals x plus 4. Is that the same thing we started with? It is. So is symmetric about the x-axis. Okay, let's check the y-axis. Okay, plugging in the negative x plus 4, we get y squared equals -x plus 4. That is not what we started with, so it is not symmetric about the y-axis. So not symmetric about the y-axis. Okay, one last thing to check. It's going to be our origin. Check -y, -x, plugging that in. So -y squared equals -x plus 4. So me y squared equals -x plus 4, which is not what we started with originally. It's not the same thing as that. So it's not symmetric about the y-axis, or it's about the origin. Okay, the last thing we're going to do is graph. So this one is a little different. It's going to be a type of quadratic because we have the x squared. But let's go ahead and do our table of values. Okay, so x and y. If x is 0, pick y as 0. Let's do same thing I always do. Okay, when x is 0, plugging that in, that's going to be y squared equals 4. Ooh, running out of room, so you're going to do this on scratch paper. Taking the square root of both sides, we get y equals plus or minus 2. Ooh, that is 2 points right there. Okay, so x is 0, y is plus or minus 2, plus 2, so 0, 2, plus and minus 2, 0, -2. Okay, picking an x, or picking the y value of 0, what do we get? So when y is 0, we get x plus 4, subtract 4 from both sides, so -4 equals x. So -4, so that's 1 point right there. 0, or -4 is 0. 1, 2, 3, 4, -4 is 0. Which means we only need 2 more points. So I'm going to go ahead and white out this point. And x value of 1. Let's see what we get. An x value of 1, so y squared equals 1 plus 4. Y squared equals 5. Ooh, square root of both sides. That's going to give me that plus or minus again. So y equals plus or minus the square root of 5. Which means I have 2 more points. Plotting square root of 5. What is that? Well, the square root of 5 is slightly bigger than the square root of 4. And remember, the square root of 4 is 2, so that means the square root of 5 is just a little bit bigger than 2. So we can plot that. It's a little bit bigger than 2, so let's go 2.2. Okay, plotting that, we have x value of 1, so we have the point 2.2. So 1, 2, about there. 1, 2.2. And the other point, 1, negative 2.2. 1, 2.2. Okay. And we now have 5 points, which means we don't need that last point. Ooh, I graphed that a little far. Should be about more like there. Okay. Oh, interesting. So now notice, this is what you might call a sideways parabola. Because instead of the x being squared, it was the y value squared. So there we go. It's like a sideways parabola because we got that y squared instead of the x squared. Okay. All right, and if you wanted to go ahead and check the symmetry, take another sticky note, graph it entirely. In fact, let's do that now. Let's check the sticky note symmetry on this one. Can we see it? Yeah, we can kind of see it. So if I regraph it here, let's check the symmetry about the origin. If I was to go ahead and flip it, is it symmetric about the origin? So flip symmetric about the origin. That means we go like that. It is not symmetric about the origin. Okay. Let's see, is it symmetric about the y-axis? Okay, symmetric about the y-axis means we go ahead and take it and flip it on the y. So here's the y, flip it. Is that symmetric? No, it's not the exact same graph. Okay, let's go ahead and check if it's symmetric about the x-axis. So here's the x-axis. Let's see if we flip it, will it be symmetric? And look at that, it lines up perfectly with what we used to have. So yes, it is indeed symmetric about the y. Okay. Oh, sorry, I said the y. Sorry, it's symmetric about the x-axis. Sorry, when we fold up over here on the x-axis and we flip it, it's symmetric about the x-axis. So it's not symmetric about the y or the origin, but it is symmetric about the x-axis. Okay, and there we go. That is it for 1.9. There's our written homework due by the end of the week. If you have any questions, please feel free to email me.